Hi, and welcome to this session on API patterns and architectures. We're going to be talking about RESTful APIs versus GraphQL APIs and some of the pros and cons of using each one. My name is George Mao, and I'm the head of Worldwide Solutions Architecture for AWS, and specifically focusing on serverless computing. Over the next 30 minutes, we're going to compare RESTful APIs versus GraphQL APIs. We'll talk a little bit about two of our services, Amazon API Gateway and AWS AppSync, and how they can help you power serverless APIs. And then we'll finally close out and help you decide on how to choose between these two different API patterns. And we'll provide you a few resources to help you get started. So at the very beginning, an API, or application programming interface, is basically a way to abstract away the underlying details of your backend implementation. For example, a client who connects to your API doesn't need to know what the backend servers are or what the backend databases are. You could implement the backend in any technology that you want or any database platform that you choose. REST and GraphQL APIs actually have many similarities. For example, they both operate over the HTTP protocol, but most of them use HTTPS. Also, they're both stateless communication platforms. For example, the client and the server don't need active connections, and they don't need to maintain state. And finally, both of these platforms and these patterns standardize the ways that clients and servers interact with each other over HTTP. So we all know what REST is, right? It's been around since about the year 2000, so almost 2 decades, and it's basically used everywhere and across almost every single API platform. It stands for Representational State Transfer, and most of us deliver REST APIs over the JSON payload format. But what is GraphQL? So GraphQL was actually created by Facebook in 2015, and it has recently been open sourced to the GraphQL Foundation in 2018. So most developers implement GraphQL APIs over the JSON payload format as well, but it doesn't have to be. You can choose whatever format you like. So let's take a little comparison between REST and GraphQL APIs. For the endpoint URI or URL, REST APIs will always use the base URI or domain of your API. So that might be api.anycompany.com. That's the exact same for GraphQL APIs. We always use the domain or api.anycompany.com. And you can choose any domain that you want, any subdomain that matches your API. Now for the resource path, for a REST API, the client needs to specify the resource path on the server. For example, the client would specify /weather or /restaurants. With the GraphQL API, this is much simpler, right? Clients always specify a static path, and that's going to be /GraphQL. Now, for passing parameters into the REST API, with REST API, you typically have 3 different options. You can use path parameters, or query string parameters, or you can deliver those parameters in an HTTP payload. So for example, if you specify zip equals 11111, that is providing a path parameter to your REST API. Or that is providing a query parameter to the REST API. Or you could use the /menu path to provide a path parameter. With GraphQL APIs, you just specify all of these details in the HTTP payload using a GraphQL query. You typically don't provide path or query string parameters. And finally, the HTTP method that you use to interact with a REST API is specified by the client, and it's something that the server needs to listen for and accept. And these are going to be typical HTTP verbs like get, post, update, or delete. With GraphQL APIs, we typically only use post. So as we can see here, GraphQL APIs are a little bit more straightforward in terms of how a client interacts with the service. So let's cover REST API concepts quickly. REST is essentially designed for servers. Clients need to send requests to the servers by combining a resource path with optional path or query string parameters and use a specific HTTP method, or sometimes referred to as a verb. And let's take a look at a couple quick examples. Down below, if you see the /weather path, we're providing one single query string parameter called zip, and we're specifying that value to be 11111. And I'm using the get method to interact with this API. I could also use a path parameter. So in the second example, in the middle, we have /restaurants and providing that parameter using an optional path of 11111. So servers basically return responses with a static schema, and it's pre-programmed, and the payload format is static. So clients must consume that response and then parse it for the details that they need. So with HTTP methods, when you're using REST APIs, the client will specify the method that indicates the intended action that they want to take. For example, if they're specifying a post method, this is typically used to create or add records. If they're specifying get, this is typically used to fetch or read data from an API. Same with put, patch, or delete. Delete typically says I want to delete or remove some data from the API. So the client is responsible for choosing the correct HTTP method to use. So let's take a look at an example of an API where I'm going to list all restaurants that are in a specific zip code. I want to search for restaurants in a zip code such as 11111. So in this case, because I'm pulling information or reading data, I'm going to use the get method. I'm going to interact at the api.anycompany.com domain, and I'm going to call this /restaurants resource path, providing it a single query string parameter called zip. In this case, I am hosting my API on a serverless platform using Amazon API Gateway, and I have AWS Lambda set up to provide my compute backend. When this request goes through, API Gateway will ingest the request and then send the JSON payload back to the consuming client. And that JSON payload might look something like this. In this case, we just have 4 restaurants that are being returned that belong in the 11111 zip code. Those are example Corp Pizza, Burger, Pho, and Tacos. So if I wanted to list all restaurants in a zip code, but also provide the menu for each restaurant, there's a couple of different ways to do that. In this option, I'm basically providing the option to list a menu option using a query string parameter. So as you can see here, my request that I make now includes a zip parameter as well as a menu parameter of yes. So when this happens, the client sends a zip of 1111 and a menu option of yes to API Gateway during the request. API Gateway will automatically parse that request and then forward that downstream to your Lambda function. And your Lambda function is responsible for performing the query into your backend database. The response payload might look something like this. So in each of the responses, the restaurant will now include a menu with an array of the menu options that restaurant can provide. Now, this isn't the only way to implement this. You could have done any one of these options. So if you wanted to provide the optional menu for each restaurant, you could use query strings, which we just saw, but you could also use path parameters, or you can just simply create additional resources, right? So you could have created a new resource called /restaurants with menu. So the point here is that there are multiple different ways in a REST API to build an API, but you have to understand whether you're using query strings, path parameters, additional resources, or any combination of these settings. So now let's move over to GraphQL API concepts. GraphQL is essentially a strongly typed query language that's designed to allow clients to ask for the data that they want. So a client can send requests by combining a static /GraphQL path with an HTTP post, and then pass the post body, which is the GraphQL query in that body. So clients are very simple, and they just have to adhere to this format. So down below, you can see we're going to use /GraphQL, and we're going to send a post HTTP method to my backend. The server is going to respond according to the requested field specified in the query. For example, if I have an API that's a weather API, I might send this as my GraphQL query. I might say I want to get the weather for a specific zip code, and for that zip code, I want the current temperature and the forecast. Or if I wanted to go back to the restaurant example, I might say, give me all restaurants, so get all restaurants in a zip code, but I want the name and the address of that restaurant. So a client will construct this query and then deliver that query in the HTTP post body. So at the heart of GraphQL is basically a schema. So a GraphQL schema consists of 3 things. You have a type, a query, and mutations. So a type in our example would be restaurants, right? So we're going to be working with an object called a restaurant. And a restaurant can have many different properties, but we're going to define a restaurant to have an ID, a name, address, state, zip, as well as an optional list of menu items. So your object types could be restaurant, could be menu. On the right here are two things that we need to watch out for when we're creating GraphQL schemas. When you create queries, they're used to fetch data, right? So get all restaurants is a query that we're going to use to fetch a list of all restaurants. Another example would be get restaurant. So if you want to fetch a single restaurant with a specific ID, you might create a query that says get restaurant. And then when you want to modify data with GraphQL, you use mutations. So on the bottom right, we can see that I'm adding two mutations. One is for adding a restaurant, and another is for deleting a restaurant. So let's take a look at how GraphQL works in this case. So if we want to list all restaurants in a zip code, back to our first example, we're going to do an HTTP post because GraphQL typically would only accept requests over the post method body. And we're going to invoke a /GraphQL static path. So every single request will flow to the backend GraphQL API service in this exact format. AWS AppSync is a managed service that's going to help us create serverless APIs for GraphQL. And then at the heart of AppSync is what we call AppSync resolvers. And resolvers help us resolve many different data sources on the back end. And we'll talk about that in the next couple of sections here. So here's our first example. If I want to get all restaurants, my client will construct a query that looks like this, get all restaurants, and I want the name and the address. In this example, my client is going to send a post payload including this query, and the AppSync service will be responsible for parsing it, invoking my resolvers, and providing the responses. If I wanted to include the menu option here, so if I'm interested in all restaurants in a zip code and their menus, as a client, the only thing I have to change is include the menu attributes in my query. So as you can see here, I'm including a new field called menu. And then I want the names of the menu items. If I also wanted more information about the menu, for example, I want the name, the price, and whether or not the menu item is gluten-free, as a client, I simply have to include that in my query. And then my backend GraphQL API would understand what I want and provide the specific results back to my client. So let's jump into Amazon API Gateway. API Gateway is a managed service that helps you create easily scalable and cost-effective RESTful APIs. You basically only pay for the requests that your customers make. API Gateway is fully managed. It allows any consumer, whether it's a mobile front end, IoT device, mobile device, desktop device, all of these can consume REST calls using Amazon API Gateway. API Gateway is directly integrated with Amazon CloudWatch, which provides you all of the logging and metric capability for you to analyze and monitor your API. And then API Gateway can invoke nearly any backend that you need. We can talk to Lambda functions, Kinesis data streams, any EC2 instance on the backend, DynamoDB, or anything that is privately protected in your VPC. So here's an example of the same resource that we've been looking at. If I created a restaurants API, an API gateway, it might look something like this, right? I might have a /restaurants and a /restaurants with menu. All of these are going to be implemented with AWS Lambda functions to perform all of the business logic. Instead, all of these would be implemented separately though. I'd have different resources invoking different Lambda functions that consume different inputs. Right? The first one is using query string parameters. The second one is using path parameters. And the last one is using a completely new resource with a path parameter. So let's take a look in detail of how API Gateway actually processes a request. When it receives a request, in this example, on /restaurants with a path parameter of zip and menu equals yes, API Gateway will parse that response. It will construct a standard payload format, which we currently call payload format version 2.0, and then pass that payload format downstream to your Lambda function. Your Lambda function would simply parse this input format and look for the details it needs, and then make the query to their backend database. In this example would be DynamoDB. So let's take the same comparison and look at how AWS AppSync works for creating serverless GraphQL APIs. AWS AppSync is fully managed and is also serverless. It can interact with also nearly any backend that you need, and this is done through resolvers. We talked about this a little bit earlier, and we'll jump into this in the next slide. But resolvers can interact with nearly any data source. This can be Amazon DynamoDB, could be Amazon Aurora, Elasticsearch, Lambda functions, or any HTTP endpoint. And the great thing about AppSync is that it's fully integrated into CloudWatch. So you have the ability to monitor your API and get all the logs and interface with monitoring tools. So this is an AppSync resolver. Resolvers are responsible for retrieving fields from data sources and then mapping them to your schema. So remember, our schema for our restaurant was defined on the left here with ID, name, address, state, zip, the type, and also a list of menu items. So I'm going to map, in this example, the first ID, name, address, state, zip, and type to a DynamoDB table. And I do that because this information is typically static. Right? This information about a restaurant doesn't change very often. So I'm going to save this information to a DynamoDB table called restaurants. I'll create a resolver to map to this backend data source. And then for my menu items, I create a different resolver. And this resolver will use a Lambda data source. So a Lambda data source will be invoked when we ask for restaurants. And I want to do this because menu items can be dynamic. They can be dynamic based on supply and demand. They can be dynamic based on pricing. There's a lot of information that can change whether or not an item is available. So right now in this example, I have two data sources and two resolvers. One that goes to DynamoDB and the second one that goes to Lambda. So let's take a look at how AppSync performs a query resolution when it gets something like this. So in this case, I'm asking for all restaurants. So I'm invoking the query called get all restaurants. And as a client, I'm asking for the name, address, state, zip, type, and the menu. So specifically in the menu, I'm also asking for name, price, and whether or not that item is gluten-free. So when AppSync sees this query, the first thing it's going to do is map the first set of data to the DynamoDB resolver, because that's how we constructed that resolver on the back end. It's going to perform a DynamoDB scan operation, because a scan operation gives me every single record in the database. Right? I want all restaurants. I'm not providing a zip code as a parameter. So it will perform a DynamoDB scan API call, and then when that completes, it will invoke a Lambda resolver for each restaurant, for each data row that came back from DynamoDB. And your Lambda function is responsible for, in real time, looking for the menu items that your restaurant can provide. So in this case, we're executing two different resolvers on the back end. Your client doesn't know that though. So your client simply is making one HTTP call to your AppSync API. So let's look at another example. Let's say you're not interested in the menu. You're simply interested in a list of restaurants. So your client would remove the menu option from its query. So in this query, we're just asking for all restaurants, and then we're asking for the name, address, state, zip, and type. So in this example, your DynamoDB resolver would fire. It would perform the same scan operation against your restaurants table, and that would complete your AppSync query. So AppSync is smart enough, and it doesn't need to invoke your other resolvers because you haven't provided that detail in the request from the client. So let's jump over to modifying data, right? Let's compare how REST and GraphQL work. So on the left here is a REST example, right? We might be doing an HTTP post against the add restaurant resource. And that's common when you want to modify some data, right? You would send an HTTP post instead of an HTTP GET. And in this case, we're providing all of the data about the new restaurant in the HTTP body. So down below, we can see we're adding a new restaurant. Its address is 000 New Street, and it's in Virginia with a zip code of 11111. So on the right side here, let's compare how GraphQL works. So with GraphQL, remember, we're always using the post method regardless of what operation we're making. We're always invoking the /GraphQL query, and in this case, we're providing a mutation in the HTTP body. So a mutation is responsible for modifying data. So the mutation we defined was add restaurant. We could have said said create restaurant if that was in our schema. But in our example, this is add restaurant. And we're going to provide the exact same information as the one we saw on the REST example. It's a new restaurant that is with address 000 on New Street. So how do you decide which API pattern your team should choose? This is a pretty big decision. So one major thing you should consider is the development experience, right? With REST APIs, the client code is typically built into most JavaScript APIs. All browsers support interacting with REST APIs. For the tools, there are a lot of tools out there, such as curl, wget, postman. All of these support REST calls natively. The general support is that REST APIs are very common and widely accepted. The ecosystem is very mature, and most customers understand how to interact with a REST API. On the GraphQL side, you typically have to use an SDK to interact with a GraphQL API because you have to construct the API call. Postman does support GraphQL APIs, but the general ecosystem is a little bit less common. Most customers are on REST APIs. All right, so let's take a look at some benefits, right, that you have to evaluate. For REST APIs, the data size is going to be defined by the server, and it's going to match the response schema. For a GraphQL API, that data size can change depending on the data that's requested by the client. So it's going to be based on how much data you think your backend will return on a daily basis. Also, the payload shape for a REST API will be identical every time, because since the schema that's returned is static. With GraphQL, the payload shape is completely defined by what the customer and the client asks for. For client support, as we talked about, REST APIs natively work in all modern browsers. With GraphQL, you typically have to use JavaScript libraries that are third-party. So there are a lot of considerations that you should consider when you're working through your choice. Number one is how many data sources do you have? If you have a lot of data sources, you might want to go with GraphQL APIs because it can abstract away the different data sources on the back end and simply invoke the correct resolvers that map to those data sources. Do you expect your data sources to change a lot? If you do, this might be a candidate for GraphQL again, since you can change your resolvers easily. And then what kind of clients do you have for your API? Do you control your clients? Right? If you don't control your clients, it might be difficult to deploy a GraphQL client. And finally, what's the skill set of your developers? If your developers all understand REST APIs, it may not make sense to convert your entire platform to GraphQL APIs. Right? That might take a lot of time. So we have a lot of resources. I want to leave you with 4 different links that you can use to get started. On the top is REST APIs and how you can get started. There are a couple of different workshops that you might want to jump through to get some hands-on experience with API Gateway. And then on the bottom is GraphQL APIs. You can use these links and the Starter Developer Guide to help you get started with GraphQL. So the final thing I want to leave you with is that when you use AWS AppSync or Amazon API Gateway, both of these provide you with a serverless way of hosting and building APIs. You never have to worry about all of the infrastructure and the heavy lifting that's required to scale, deploy, and manage your APIs. The first thing that you have to do is write the business logic that matters to your business. There are a couple other sessions at reInvent that have really good information about both API Gateway, HTTP APIs, as well as modern applications with GraphQL AppSync. So definitely check out these 2 other sessions, and these will provide you good information on both platforms. Thanks for your time, and I hope you enjoy the rest of reInvent. And please complete the session survey, as your feedback is super valuable to helping us make all of the future sessions better.